And now we will continue with limiting reactant. Okay. So, tadi kita dah tahu pasal stoichiometry. So, itu adalah bila kita tahu mana excess reactant, okay. Yang mana satu dia tak ada masalah lah kalau awak just guna satu je. Awak dah tahu siap-siap which reactant yang akan limit, akan tentukan the number of product. So sekarang ni sometimes the reactants used aren't usually present in exact stoichiometric amounts. That means some reactant will be used up while the other will be left over. So maksudnya antara 2 reactant tu atau 3 reactant tu yang akan melimitkan produk awak. Okay. So when 2 or more reactants are combined in non-stoichiometric ratios, the amount of product produced, okay, is limited by, okay, produk awak dilimit terhad oleh reactant that is not in excess. Maksudnya limiting reactant. So limiting reactant, okay, is a reactant that is completely consumed, habis kita guna dalam reaction, and dia lah, it is the one that will limit the amount of product that is formed. Okay, maksudnya limiting reactant will will give the amount of product, right? So when you do stoichiometry, okay, you must find the limiting reactant in order to find the amount of product that is formed. Okay, to relate those two. So yang lagi satu tu is the excess reactant. Excess maksudnya terlebih. So this reactant remains after the reaction. So you will have extra of this. It is present at greater quantity compared to the limiting reactant. Alright? So let's see how can we understand this concept of limiting reactant. Okay, let's first consider a bicycle. Okay, bicycle. So in order to form one complete bicycle, you will need 1 frame and 2 tires. Betul? Okay. So let's say if we have 1 frame and 2 tires, okay. So maksudnya ini adalah perfect combination lah. So dia adalah stoichiometrically equivalent. Okay. So let's say lah if we have 2 frames, okay, and 5 tires. Alright, macam kat bawah ni. Okay. Siapa yang akan melimitkan the amount of bicycle we will produce? The product. Frame ke tire? It will be the frame. Okay, in this case it is the frame. So itu kalau awak ada 2 frames and 5 tires. So let's say if we have 1 frame and 5 tires, siapa yang akan limitkan the amount of bicycle that we will produce? It will still be 1 frame, betul tak? So kita boleh buat 1 bicycle je. So maksudnya the frame will tentukan how many bicycle that we will produce. Okay, so maksudnya the more atau the number of frame, okay, the number of frame when it is the limiting reactant will tell you the number of bicycle that you will produce, bukanlah tire. So let's say if we have 3 frames and 5 tires, adakah kita akan tengok nombor je? Tak kan? Kita tak tengok nombor ni kan, and kata yang ini adalah limiting reactant kan? Bukan kan? So basically when you have 3 frames and 5 tires, in this case the tires are the limiting reactant, because this will limit lah how much bicycle you will be able to produce. So that means, okay, when you have 5 tires, how many bicycles will you produce? You will produce 2 bicycles, betul tak? Okay, so maksudnya bila awak nak cari the amount of bicycle, you will use these two comparison in your stoichiometry, for your stoichiometry. So 5 tires is equivalent to 2 bicycle. Okay, so itu kita punya from equation atau theoretically. Alright, so that is how you determine lah the limiting reactant. Okay, so let's consider a reaction. Since kita ni belajar chemistry, bukannya basikal, betul? So kita akan look at our balance equation here. So since this is the balance equation, we know that from this equation that 1 mole of zinc will react completely with 2 moles of HCl. Alright, so let's say if 2 moles of zinc were added to 3 moles of HCl, how are we going to know who is the limiting reactant? So maksudnya daripada equation ni, we need to agak lah, okay, stoichiometrically 2 moles of zinc must react completely with how many moles of HCl. Okay, so kita tulis 2 moles of zinc will react completely, react with berapa? Sini 2, maksudnya ni 1 and then dapat 2. I mean react with 2. Maksudnya kalau 2, you will react with 4 moles of HCl. Okay, so maksudnya 2 moles of zinc will react with 4 moles of HCl. Kan? Okay, so dia kata dalam eksperimen tu, dia add 2 moles of zinc with 3 moles of HCl. So kalau kita tengok sini, siapa adalah limiting reactant? Yang mana yang kurang? Yang mana yang akan limitkan kita punya produk? Okay, terang-teranglah kita nampak yang okay, we need 4 moles of HCl. So if we only have 3 moles of HCl in our experiment, is that enough? Is that enough? So no, okay. So 2 moles of zinc must react with 4 moles of HCl. So since dia only add 3 moles of HCl, that means that HCl will be your limiting reactant, while your reactant in excess or excess reactant will be your zinc. Alright? Okay, so next we are going to look at the steps to determine limiting reactant. So these are the clear systematic steps lah for you to determine the siapa limiting reactant. Okay, so first you're going to calculate the number of moles available that is given for each reactant. Okay, so find the number of moles for each reactant. Okay, reactant 1 and then reactant 2. Okay, so yang ni adalah given, right? That is given from information daripada awak punya question. And then second step is stoichiometrically. So kita buat equivalent to atau react with, produce, okay, whatever. Calculate the number of moles of reactant. So yang ni yang kita compare tadi lah, the number of moles. Okay, so dari sini kita boleh tahu the moles of reactant, okay, that dari theoretically lah, okay, atau from equation. Ini daripada balance equation kan, sebab stoichiometry. Third step, you're going to compare the number of moles calculated needed into to number of moles available in one. So yang ni yang tadi given atau available, okay, and this one is needed. Okay, so kita akan compare. Kalau okay, the mole needed, okay, yang warna hijau tu, is more than the number of moles available or given, that means that is your limiting reactant. Reactant tu adalah limiting reactant. Okay, sebab kenapa? Sebab mole available, okay, yang awak ada lebih kurang daripada mole needed. Okay, so maksudnya tak cukup lah. So dia yang akan limit berapa banyak produk awak akan form. Okay, if the mole needed is less than the mole available, okay, maksudnya awak ada lebih of that reactant, okay, mole dia lebih, then that will be your excess reactant. Okay, so once you know who is the limiting reactant, we are going to apply number of moles of limiting reactant that is available to determine the product. Okay, alright, so example 1. Okay, we will look here. So read the question first. It says a 10 gram of hydrochloric acid was reacted with 10 grams of calcium carbonate. Kenapa lah ada kat sini, salah ni. Okay, to produce carbon dioxide gas. Determine the limiting reactant. So, to find the limiting reactant, we are going to compare the number of moles of reactants theoretically atau from balance equation with the number of moles of reactants given. Okay, so since we are given the mass of your two reactants here, okay, we can easily find the number of mole of HCl that is given or available, okay, and the number of mole of calcium carbonate. Okay, so what you're going to do first, okay, first balance equation, write down the information, make sure your equation is balanced. Okay, then to find limiting reactant, we're going to find the number of mole of these two. So since we're given mass, we just find the number of moles. Okay, so this will be the number of moles of reactants that are given or available. Okay, ini yang awak ada dalam awak punya eksperimen. Okay, and then we are going to use stoichiometry. Okay, so from this balance equation, we know that 2 moles of HCl will react with 1 mole of calcium carbonate. So we are going to write that down here. Okay, kita guna stoichiometry to find, okay, let's say when we have 0.274 mole of HCl, you will need to react this amount with, okay, this amount of calcium carbonate. So yang ni awak basically bawa 2 turun bawah, bawa ini naik atas. So kalilah sini. Okay, so then you find the number of mole of calcium carbonate that is needed. Alright, so since we already have the mole of calcium carbonate needed and the mole of calcium carbonate that is given, okay, we are going to compare these two. Compare. Alright, so kita tengoklah, kita bandingkan. So, dari situ kita tahu the mole of calcium carbonate given, okay, yang kita ada dalam tangan kita contohnya, is less than the mole of calcium carbonate that we need. Okay, so that means the calcium carbonate is your limiting reagent or limiting reactant, sebab kita tak cukup daripada yang kita perlukan. Okay, so let's say, Miss, boleh tak kalau saya guna HCl, saya letak HCl instead of calcium carbonate, nak cari mole tu, boleh je? Okay, boleh je. So beza dia kalau awak guna, bila awak guna let's say kat bawah ni kan, instead of calcium carbonate, awak cari HCl punya, okay, mole given dengan HCl punya mole needed, okay, you will find that the bracket is reversed, okay, because HCl is your excess reactant. Okay, so dari sini awak boleh conclude that HCl needed is less than HCl given. So maksudnya awak terlebih lah HCl tu. So that means HCl will be your excess reactant. So last pun, you will conclude that calcium carbonate is your limiting reagent. Okay? So make sure to have this point. This one is important. Alright? Okay, so now that we find the limiting reactant, we can find the mass of carbon dioxide gas that is produced. Okay, so daripada balance equation ni, kita dah tahu, daripada A, kita dah tahu yang calcium carbonate will be the one limiting the amount of carbon dioxide product that is produced. So maksudnya, kita akan guna stoichiometry, where, okay, kita tahu 1 mole of calcium carbonate will produce 1 mole of carbon dioxide. Okay, so macam biasa, we will write down 1 mole of calcium carbonate produces 1 mole of carbon dioxide. Okay, so since we already know the number of mole of calcium carbonate that is given from the previous question that we found, okay, daripada this mass, ini yang kita ada, you know that this amount of mole of calcium carbonate will produce the same amount of mole of carbon dioxide. Okay, so now that we found our mole of carbon dioxide, okay, hati-hati, sometimes you can forget this. You will convert the number of mole into mass. Okay, so just use this formula and you will get the mass of carbon dioxide. Yay! Okay, alright, so lastly, the question says, the question wants you to determine the mass of unused reactant. So unused reactant maksudnya awak punya excess reactant lah. Berapa banyak dia tinggal? Okay, siapa excess reactant kita tadi tu? Siapa? Antara dua ni, siapa? HCl. Okay, so to find the mass of unused reactant, okay, we will minus the given amount of reactant with the used amount of reactant. So maksudnya given ni kita dah tahu sebab dia given is 10 grams. Betul? So maksudnya kita kena carilah berapa banyak mass of HCl is used. Okay, so maksudnya kita akan buat stoichiometry jugalah. Okay, so since HCl is the excess reactant, how much of HCl is left? Okay, from equation tengok, okay, kita akan tengok calcium carbonate dengan HCl punya relationship. Okay, so 2 moles of HCl will react completely with 1 mole of calcium carbonate. So since calcium carbonate ni kita punya limiting reactant, okay, HCl is our excess reactant. Okay, kita nak cari berapa banyak HCl was used. Okay, so when 1 mole of calcium carbonate was reacted, so 1 mole of calcium carbonate must react with 2 moles of HCl. Okay, so that means 0.999 mole of calcium carbonate will react with berapa banyak HCl? Maksudnya awak kali 2 je lah. Ini kali 2. Okay, so you find the mole of HCl that is used. Alright, so daripada mole of HCl, okay, so since we already know the mole, you can find lah the mass of HCl that is used. Betul tak? Betul tak? Betul tak? Miss, betul tak? Betul lah. Okay, so kita dah tahu berapa banyak use kan. So maksudnya last adakah ini final answer? Adakah? Bukan, okay, this is not the final answer. So ini baru awak dapat beberapa markah. So final answer awak kena tolak lah 10 grams dengan this. Okay, to find the mass of unused excess reactant. Alright, so nanti dalam kelas nanti saya tanya. Okay, so example ni saya tak nak buat, awak buat. Okay, and then finally we are going into percentage yield. Okay, percentage yield ni I think you have learned during school times kan? Okay, like it was just yesterday. So percentage yield, so basically it is this formula where you divide the actual yield, berapa banyak awak memang dapat daripada awak punya experiment, okay, divided by the theoretical yield. So this one is from equation, and then times with 100, and you will get your percentage yield. Okay, so kita nak tahu berapa banyak yield kita dapat, right? Percent dia. So theoretical yield is based on balance equation or stoichiometric calculation. Your actual yield is from experiment. So actual yield is usually given lah. Okay, sometimes macam terbalik, dia tak bagi ni ke, and then dia bagi ni ke, tapi selalunya yang ni bagilah, yang ni dia bagi. Okay, so for example, okay, for this question, okay, titanium is prepared by the reaction of titanium chloride with molten magnesium between 150 degrees Celsius and 1150 degrees Celsius. So they already gave you the balance equation where 1 mole of titanium chloride will react with 2 moles of magnesium to form 1 mole of titanium solid and 2 moles of magnesium chloride. Okay, so in a certain industrial operation, okay, this mass in grams of titanium chloride are reacted with this much of magnesium. Okay, so sekarang ni dia dah bagi tahu the mass of your titanium chloride and magnesium, your two reactants. So since they have given you the mass of two reactants, okay, what you have to do now is to find the number of moles, okay, according to the mass given. Okay, so you will find the mole given for titanium chloride and magnesium, and then from here you will find the limiting reactant. Adakah titanium chloride atau magnesium the limiting reactant? Okay, so once you have that, you will know, okay, which of the reactants to apply to your stoichiometry calculation. Okay, who will limit the formation of titanium solid. Alright, so dari situ awak boleh lah cari the theoretical yield atau basically the mass of titanium in grams. Okay, titanium. Okay, so actually what happens here is the first part is you want to find the limiting reactant lah. So I will just go through this briefly. Okay, macam apa yang saya cakap tadi, you have to start with balance equation, and then write down the information. Okay, you have the mass. So since dia bagi tahu dua reactant tu, you find the mole of the two reactants. Okay, the given number of moles, right? So from there you will use stoichiometry from equation pula. Ini daripada balance equation, awak tengok the mole needed berapa. Okay, so ini adalah given tau, yang awak guna mass tadi ni, ini adalah given. Okay, yang ni adalah needed. Okay, so sekarang kita nak cari limiting reactants apa. So we found out that, okay, magnesium is the excess reactant sebab the mole of magnesium given yang awak ada is a lot, so much more, so extra daripada what we need. So that means that magnesium is excess lah. So therefore automatically titanium chloride is your limiting reactant. So now that we know that titanium chloride is your limiting reactant, okay, we will use titanium chloride to find the mass of tin form. Okay, so maksudnya sekarang kita akan gunalah the mole of titanium chloride untuk bandingkan dengan the mole of tin. Tin pula, titanium. Okay, titanium solid. So you find that you will form 1.87 times 10 to the power 5 moles of titanium solid. Okay, so dari situ awak bolehlah cari mass, betul tak? Because mass is just mole times molar mass. Okay, so you find the mass. So this is your theoretical yield of titanium, or theoretical mass. Okay, so since dalam soalan ni for B pula, dia kata calculate the percentage yield if 7.91 times 10 to the power 6 grams of titanium are actually obtained. So maksudnya itu adalah your actual yield. So senang je, just use the formula tadi, actual over theoretical. Okay, times 100. Okay, masukkan je. And you will find your percentage yield. Okay. Alright, so ini saya tersalah. Ini tak ada percentage kat sini. Tapi kat awak punya final answer, you will have percent. Okay. Alright, so that is the last example for today. So make sure to do the examples and exercises macam biasa, and we will maybe discuss on Thursday. Okay, or Wednesday. Tengoklah miss ni macam mana. Okay. Alright guys, thank you so much, and feel free to ask me any questions, discuss with your friends, and I'll see you soon. Bye.